Yes, my dear student, I greet you all. Welcome to Vision Plus. Here, I'll be taking you through chemistry. And so far, we are in chemical properties of methane. We are in organic chemistry. You may call me Peter or simply Wow Chemist. So here, I'll be taking you through organic chemistry. And so far, we have reached to the chemical properties of methane. We have talked about the introductory part. We have also talked about the classification of hydrocarbons. But right now we are majorly focusing on methane gas, which is under alkane. So today we want to look at the chemical properties of methane. How does this methane behave chemically? In other words, how does it react with other substances? That's what we are meaning here. So we are saying, when we look general knowledge, we are saying alkanes themselves, when we look at alkanes themselves, these organic compounds or hydrocarbons, they are relatively what? Unreactive. Why? Because the explanation is very simple. We are saying that these bonds in the middle, C to C bonds and the C to hydrogen covalent bonds make the what? This one very. Now, the simple explanation is that this bond we are saying and these other bonds, these covalent bonds, they are really very, very, very strong. Such that if you want to break this bond, you want to break it. For you to break it, it requires much energy is required to break the bond. In most cases, it is around 300 to 400 kilojoules per mole. So, because of that, we are saying that this bond is actually very, very strong, and that make it for these hydrocarbons to be relatively unreactive. So let's look at the combustion. When we say combustion, we are meaning burning. How can methane burn in air or in oxygen? So you're saying methane burn in excess. So what you're going to mark is that excess what? Excess oxygen to form carbon dioxide. If you don't want to call it carbon dioxide, you can call it carbon dioxide. And also water is being formed in the process. And the equation here is just very simple. You get your methane gas reacting with oxygen, which is also a gas, to give us carbon dioxide and water. And when we look at this thing critical, of course, you can balance. In organic chemistry, we don't encourage balancing the equation, but this small one you can balance. So here we shall have something of this kind to give us carbon dioxide gas plus water. So here we have four molecules of hydrogen atoms. So, and here we have two. So simply I can put this to increase this one to be four. So I will say 2 times 2 allow 4 hydrogen atoms. Then that means I have increased the moles of oxygen atoms. So if I have increased the mole of oxygen atom, I'll say these two plus these two, I'll get 4 moles of oxygen atom. And simply, I'll come to the reactant side and say, also I have to put 2 here to make oxygen what? So I'll say 2 times 2, oxygen is 4, this side. Then when we come to the product side, we shall have oxygen 2. These two belong to hydrogen and oxygen. So therefore, they are sharing it. And if they are sharing it, also oxygen become 2. So we shall have 2 plus 2. We shall have 4 moles of oxygen. Then now when you look at carbon, we have carbon is 1, carbon is 1, hydrogen 4. Then these two, since it is shared by hydrogen and oxygen, we shall say it 2 times 2, we shall get 4 moles of oxygen. Now, that is the reaction when oxygen is in excess. Now, it is in sufficient supply of oxygen. We form two products. We shall have carbon monoxide and carbon itself being formed. And then the same water is being also produced when it is in limited supplies, or we say insufficient supplies of oxygen. Now, when we look at these equations, we are saying we want to balance this equation. We shall simply first balance the oxygen atoms. Here we have seen we have 2 moles of oxygen atoms, and here we have This and this, we have 2. Of course, let's go to hydrogen atoms. Hydrogen atom, I have 4 here, then here I have 2. So that means if I'm going to put 2 here, we're going to have 4 number of oxygen atoms. So I'll increase this one to 4 moles of what? Of oxygen. So if I increase down to 4 moles of oxygen, then that means I'm going to have what? 8 moles of hydrogen. I'll say 4 times 2, I'll have 8. So I'll come and put 2 here, and I'll have 2 times 2, I'll also have 8. So I've increased the moles of carbon out of this side also to be 2. So that means I have to come this side and add 2. So I'll have 2 carbons, then also oxygen, I'll have 2, of course, plus 4, we shall have 6. So I'll come this side and say it. I have to put 3 here. 3 times 2, I'll get 6. So when we want to check throughout the equation, we shall say carbons 2. Carbon also, there are 2 moles of carbons. Then also hydrogen, we shall say 2 times 4, we get 4. We get 8. Then here we shall say 4 times 2, we shall get 8. Then when you come to oxygen, you say 3 times 2, you get 6. Then we shall have this 2 is being shared by carbon and oxygen. So if it is being shared, that means the 2 belong to carbon and oxygen. So if that is the case, we shall also have 2 plus 4, because this 4 is shared by hydrogen and oxygen. So we shall have 6 moles of oxygen also on the product side. Then let's come to the last equation. The last equation, since we are saying when we burn methane gas in limited supply of oxygen, we can also get the shoot, and the shoot is carbon, which is black in color. So when we look at this one, we shall see that we have carbon, is 1 here, carbon 1, then oxygen, we have 2 here, then oxygen this side, we have only 1. So we shall put 2 here to increase the mole of oxygen. So after putting the 2 here, we shall now say it's 2 times 2, because the 2 is shared by hydrogen and oxygen. So 2 times 2 we shall get 4. Then this side also we shall have 4 hydrogen atoms. So let's come to oxygen atom. We have 2 here, of course. Then this 2 is shared by hydrogen and oxygen. We also have 2 this side. And this equation is balanced. So that is the conversion part for methane gas. So here, a question will be said, and I will say that write the equations when methane gas is burning excess oxygen. Then you write the equation in limited supply of oxygen. You also will be in position to write these 2 equations. Yeah. So thank you for your time.